Okay, today we're going to dig into the data behind a global health challenge that's, well, it's on the rise: renal cancer. By really looking at the numbers, the risk factors, and the geography of this disease, we can start to see a path forward, a way to fight it more effectively. So, let's dive right in. I want to start with just one number that puts this whole thing into perspective: 96%. That is the projected increase in deaths from renal cancer by the year 2050. I mean, wow. That's a huge figure, and it tells us there's a major public health storm brewing on the horizon. So the big question is, what's behind this? What's driving this trend? Is it our environment, our genes, maybe our lifestyles? Or, more likely, is it some combination of everything? Let's break down the data and see if we can find some answers. All right, first step, let's just get a handle on the scale of the problem as it stands today. What does the current global burden of renal cancer actually look like? You know, the raw numbers really do paint a stark picture. Back in 2022, we saw nearly 500,000 new cases worldwide. But if we fast forward to 2050, that number is projected to jump by over 70%. And the deaths, they're on track to nearly double. This isn't some far-off issue. It's an accelerating problem, and it's happening right now. And here's the part that's actually kind of alarming. Those projections, they're based only on population growth and people, living longer. They don't even factor in any potential increase in our lifestyle or environmental risks. And that makes understanding those other risk factors even more critical. But here's the thing. This global picture isn't uniform at all. Renal cancer doesn't affect everyone equally. Your risk can change, sometimes dramatically, just depending on where you live, your gender, and even your access to good health care. I mean, the geographic difference is just staggering. Take a country like Belarus. The age-standardized incidence rate, which is just a fancy way of saying they've adjusted the numbers to compare countries fairly, is over 14 per 100,000 people. Now compare that to Sierra Leone, where the rate is just 0.04. The data really suggest a strong link. Countries with a higher human development index tend to report more cases. There's also a pretty significant gender divide. Globally, men have higher rates of both getting diagnosed and, sadly, dying from renal cancer. And what's really interesting is that this gap is much, much wider in highly developed regions like Europe and North America, and it's less pronounced in places like Africa. So what about survival? Again, the differences are stark. A patient's 5-year survival rate can be as high as 75% in Oceania, but it can plummet to as low as 40% in parts of Africa. This really highlights a massive global disparity in outcomes, and it's almost certainly tied to things like healthcare access and how early the cancer is detected. Okay, so beyond geography and demographics, there's a factor that's, well, a lot more personal: our own genetic blueprint. Let's take a look at the role our DNA plays in all of this. While most cases of renal cancer seem to pop up spontaneously, kind of out of the blue, it's estimated that somewhere between 5 and 8% of all cases are actually hereditary. That means they're linked to genetic factors passed down through families. These hereditary cases often fall under this big umbrella term: hereditary renal cancer syndromes. To put it simply, these are conditions where a person inherits a faulty gene, and that one faulty gene dramatically raises their lifetime risk of getting kidney cancer, and often at a much younger age. A classic example of this is a condition called von Hippel-Lindau disease, or VHL. It's caused by mutation in the VHL gene, and it can cause tumors to grow in lots of different organs. But here's where it gets really fascinating. The VHL gene isn't just linked to this one rare syndrome. It turns out that this same gene is mutated in up to 90% of sporadic, meaning non-hereditary, cases of the most common type of kidney cancer. It's a perfect example of how studying rare diseases can unlock secrets about much more common ones. So, how do doctors even begin to spot a potential hereditary link? Well, they look for certain red flags. Things like getting diagnosed really young, say before age 50, or finding tumors in both kidneys, or maybe having a close relative, a parent or sibling who also had renal cancer. These are the kinds of clues that might point towards a genetic connection. All right, so from our genetic code, let's pivot and shift our focus to the factors we might have a bit more control over: our lifestyle, our habits, and our environment. First, we have to acknowledge the factors that are pretty much out of our hands. The risk goes up with age, if you're male, and if you have a certain family history or ancestry. These are sort of the cards you're dealt, the baseline risk we all carry. But, and this is a big but, this is where we can take some control. More than half of all renal cancer cases are linked to risk factors we can potentially change. Excess body weight, high blood pressure, and smoking are the big three. But things like diabetes and chronic kidney disease also play a really significant role. And this brings us to a really fascinating, kind of counterintuitive puzzle in biology. It's known as the obesity paradox. So get this. While being obese is a major risk factor for developing renal cancer in the first place, some studies show that obese patients, once they're diagnosed, often have better survival outcomes. It's a super weird finding that researchers are still trying to figure out. Now, unlike that confusing paradox, the link with smoking is dangerously clear. The research is solid. An estimated 19% of all renal cancer cases can be directly attributed to cigarette smoking. Just think about that. That's nearly 1 in every 5 diagnoses linked directly to using tobacco. So, we've broken down the numbers, the geography, the genetics, and the lifestyle factors. But the big question is, so what? What do we do with all this information? How does this data actually empower us? Well, it really boils down to a few clear, actionable steps. First, managing those modifiable risks. Working to control your weight, blood pressure, and diabetes. Second, and I can't say this enough, stop smoking. Quitting makes a real, measurable difference. And third, know your family's health history. Talk about it and share it with your doctor. It really could be the key to understanding your own genetic risk. Ultimately, all of this data is pointing us toward a future of more personalized medicine. It lets doctors move away from a one-size-fits-all playbook and toward strategies that are tailored to your specific risk profile, whether that risk comes from your genes or your lifestyle. And that leaves us with one last crucial thought. We have more data right now than we have ever had before. The real challenge is turning that knowledge into action. Could this incredibly detailed, data-driven approach be the key that finally unlocks truly personalized cancer prevention? Thanks for joining me.